Okay, welcome back. This is Business 271. I'm Dr. Yowie. This is Gaston State Community College, and we are working on problems from section 9.3 of the text. Here we're doing hypothesis test of a population mean where the standard deviation is known. This is important. We're going to be doing tests where we know the standard deviation of the population. A little later on, we'll do them where we don't. We'll be using both the screenshot here and the webcam. I hope I do it right. All right, so if we go over here to chapter 9.3 under methods, it says consider the following hypothesis test. H naught, the mean is greater than or equal to 0. The alternative is that the mean is less than 20. I'm sorry, I said 0 is greater than or equal to 20. Mean is less than 20 for our alternative. We have a sample here that we've taken, and we've got 50 observations in that sample, so n is equal to 50. Hold that up so you can see it. N is equal to 50. We have a sample mean, x bar is our sample mean, of 19.4, and a standard deviation of 2. Put that on there so you can see it. Here, we want to compute the value of our test statistic. That's first thing. Now, where the standard deviation of the population is known, we can use a z-stat. The z is equal to x bar minus mu over the standard deviation divided by the square root of the number of items in your sample here. Okay. So now all we have to do is substitute in. Better shot here. X bar is 19.4 minus the mean, which is 20, divided by the standard deviation of 2 over the square root of 50. Oops. Okay. Now we're pulling up our calculator. 19.4, we know, is negative 0.6 over 2 divided by the square root of 50. Clear our calculator here. 50, square root of that. So I've got 2 divided by 7.0710, and we'll just stop here at 7. Okay. Now, an easy way to do this is I can take, since I'm dividing 2 by this, I can take 1 over this and multiply it by 2, and I'm going to get negative 0.6 over 0.28284. Okay. Just going to show you the work we've got so far. Then we're going to go back to our calculator. We can do an inverse here, since we're dividing by this. Put 1 over it, multiply it by 0.6 in the negative, and we're going to get a negative 2.121. So my z is equal to negative 2.121. Now, the next part of the question says compute the p-value. Compute the p-value. So here, we're going to go into our tables, and we're going to look up a z of 2.12. And hold on for just a second, and I'll let you see what I'm doing. I'm going to the back of the book. I'm going to Appendix B, I believe, yes. And we're going to look up a z value of negative 2.12. Take the camera off here for a second. I'll show you how to do that. Okay, so we're going to go to page 760 of your book. And if you'll look, we're looking up a z of negative 2.12. So here's negative 2.1. We're going over. Get you a better shot here. Negative 2.1. Then we're going over to 2.10, 2.11, 2.12. And we've got a value of 0.17. So our p-value is equal to 0.0170. We can say here that there is a 1.7% chance that we could get this z value if the mean were actually 20. So if the mean were actually 20, to get a a z value of negative 2.121, that would only happen, that value or less, 1.7% of the time. So that is our p-value. Going back to our problem, part C. At a 0.01 alpha, what is your conclusion? So if our alpha is equal to 0.01, our p-value or rho value is greater than our alpha. And just to show you this, bring the webcam back up. Okay. Here is our z distribution. Here's our normal distribution. We had a mean of 20. Okay. The z at 20 is 0. We had a z value of negative 2.121. That falls over in this area, and that corresponds to an x bar of 19.4. The probability to the left here is 0.0170. We were looking for 0.01 or less, so you can see this is not in the area of rejection. Therefore, we would fail to reject H naught if alpha is equal to 0.01. Get you a look at that. 0.01 is here. 0.0170 is to the right of it. That is in our area where we fail to reject. Everything to the left of 0.01 would be where we reject H naught. everything to the right, we fail to reject H naught. So all we're saying here is that we do not have enough evidence with an alpha of 0.01 to reject the null hypothesis that, going back, that mu is greater than or equal to 20. Okay. And what is the rejection rule using the critical value? Okay, here we would, instead of calculating the p-value, we would have gone into the book, found a z-value closest to, without going over, 0.01. And by doing so, we would have come up with 2.39. 2.39. Okay? So negative 2.39, so this is using the critical value. Negative 2.39 was our critical z. We would have said, doing a one-tail test, that if z, our calculated z, is greater than or equal to our critical z, we would fail to reject H naught. If z is less than our critical value, if we calculated a z less than our critical value, we would reject H naught because we're doing a one-tail test here. Our critical z is negative 2.39. Our calculated z was negative 2.12. That is greater than, it's less negative than negative 2.39. Therefore, we would fail to reject. So we can do these problems either way. We can calculate, we can look up a critical z value. We do that by taking the alpha that we've chosen, looking on the tables here on page 760, in this case, and finding the value closest. I'm sorry, it was negative 2.33. My fault. Negative 2.33 is what we should have used. But negative 2.33, that's the closest to 0.01. Then we calculate, then we get negative 2.33 as our critical value. Calculate, giving you a look at what we did before. Calculate our z value, our calculated z, which was negative 2.121. And we found out that it was greater than negative 2.33, and it fell to the right of our rejection region. So we failed to reject H naught. Or we can calculate the z, look that z up in the book, negative 2.12. That came out to be 0.0170. We can compare that p-value to our alpha and say that p greater than alpha, therefore we fail to reject our null hypothesis. I hope this helps you. This is my first time using this camera, moving it around by hand, trying to do things on the screen and on paper. Send me an email or something and let me know if this video works for you. Thank you. Have a great day. Goodbye.